Hello there, my name is Mike, and welcome to my channel. In today's video, I'm going to be introducing a new series called Foundations that we are going to do together. And I have a very specific goal for you if you're willing to stick around for just a little bit. I want to teach you physics, and I want to teach you how to teach yourself physics. And the trick to teaching yourself physics is not to pick up a book like this. This is Nuclear Physics, written by the Werner Heisenberg. A book like this is really, really cool. And there's all this really interesting stuff about radioactivity in here and the states of nuclei and the way that matter itself is organized. Unfortunately, if you pick this up, you're probably going to be a little lost. I've got all kinds of books like this that 3 or 4 years ago, I would not know the first thing to do. Here's a pretty nasty integral, it looks like, of it appears to be a wave function. And this is in the Introduction to Quantum Mechanics section of this really cool book called Basic Concepts of Modern Physics. I'll tell you what, if you pick this up and you just tried to start learning, you would get lost, you would get discouraged. It sucks. You got to start somewhere. And as it turns out, if you're in academia and you are a physics student, the way they have done this is it's a pretty well-oiled machine. In your first year or two in college, you learn something called classical physics from a book similar to this. Now, this is a book that doesn't use calculus, and if you're a physics student, you will learn physics with calculus. What I would like to do in this series is teach you the foundational knowledge of physics that will allow you to then take all of the information you've learned, synthesize it, and learn just about any other topic in physics on your own. To go out and buy a book like this and have it all make sense. You want to learn about quantum mechanics? Who doesn't? You need to know some basics. You need to know what a wave function is. Not the quantum mechanical sense, but the nature of a wave. The nature of a string that you can pluck and watch vibrate in a certain way. If I drop a pebble in a pond, the way the waves propagate out, they're analogous to probability waves. There are these really cool dynamic ways that we interpret the world. And it just so happens that there are foundational elements of mathematics and physics that translate to all these corners of reality we would have never expected to see them in. And the wave function is probably the biggest example of that. The fact that light makes patterns of interference, and the fact that a particle, a particle of mass can do that. If you know what you're doing and you've got a very airtight experiment, it's crazy. And it's beautiful, beyond belief. So what I want you to do in this course is follow with me. This is a textbook called Physics by Cutnell and Johnson. I famously bought it for $4.99 at a Goodwill. You can find these all over the net for 15, 20 bucks. Get one of these, check Barnes & Noble, check your local Goodwill, follow along with me. Because what we are going to do is get you to a point where the equations stop being numbers. And by the end of this series together, I want you to be able to look at something like these electric potentials and the vector fields that come out of electricity and magnetism and understand what they're actually doing. You know, picture the fields, right? These don't have to just be numbers and equations. They can be something more than that. They can be, you can feel them. You can feel the interaction. Seriously. You do enough of the math, and a very interesting thing happens by the 14th or 15th equation. All of a sudden, like, you stop seeing the numbers as variables, and you can start feeling the interactions between particles. You can almost picture the particle start spiraling in on itself if it's in a magnetic field, and you can feel the charges repulse each other. You know, these aren't just numbers on a page. It's the nature of reality itself, and you can uncover it, and you can learn it. So what I want to do in this series is get you there. The way we're going to do this is I've already had the first video on my channel, so go take a look. We're going to start with a discussion of units. And by the end of it, we're going to go through pretty much all of what we call classical mechanics. So I'm going to teach you Newton's equations. We're going to go through the nature of waves. We're going to go through electricity and magnetism and the nature of matter. And finally, by the end of it, we're going to tackle some problems from a higher level book like this. And I think you're going to find that you're going to be very interested. So if you want to do this, stick with me right now. Leave a comment saying you're interested below. And we can make this a two-way street, a discussion between people who love this subject. That's what I'm looking forward to. So take a look at my channel already. I've got a ton of different physics videos. Let's learn together. And by the end of it, I think you're going to be very empowered by the knowledge that you've learned, that you've taught yourself. All right, I look forward to seeing you in the next video. And until then, like, subscribe. I'll see you in the next one. Peace.